Woohoo, we are recording, and this is the Math 40 Chapters 6 and 7 practice test, which is split into two pieces because it's just kind of a long test. We're on problem 4, and we have now made it into rational expressions. So in other words, we're in Chapter 7. And I know this is going to seem simplistic, but I've got this lovely little helper to remind us how to work with fractions. And I'll just remind you that when we are going to be dividing, whether it's a simple fraction like 1/2 or 1/3, or more complicated rational expression with, x's and numbers and all sorts of interesting stuff. But I'll remind you that when you're dividing in fraction land, you flip the second fraction over. So in order to do this division here, we're first off going to have to consider that 7x plus 14 has to be written as a fraction. The easiest way to do this is to simply put it over 1. Over 1 makes everything a fraction. It's just amazing the way that works. Okay, so if I'm dividing, remember that means the second rational expression has to flip upside down. So I've got an x squared minus 4 all over x minus 2. Change that to multiplication, flip this upside down. Now, there's a bunch of stuff happening here. If I were you, or if you were I, or something like that, these two would be winking at each other. They really want to cancel. Can we cancel? And the answer is no. There are 2 terms here, there are 2 terms here, there are 2 terms here. There's a minus, there's a plus. Whenever there are minuses and pluses, they don't like you. They don't like parties. They're going to come in, they're going to break up the party, they're going to make everything not fun, and you're going to have to factor the hard way. So, minuses and pluses, oh, now we can't have fun. This is why we can't have nice things. However, it turns out that we learned how to factor, and in fact, these are not hard ones to factor. X squared minus 4, remember our friend, difference of 2 squares? Yep. So x squared minus 4 factors as x plus 2, x minus 2. Down here, I've got an x minus 2. I'm going to tuck it inside parentheses to make it easier to see what's going on. You don't have to do this. Now over here, I'm seeing 7 and 14. It's like, oh, this is never going to work with anything. And then I realize, wait a minute, there's a common factor here. I could factor out that 7. And if I factor out that 7, then I've got 7x leaves x, and 14 leaves 2. Oh my goodness, oh my gracious, look at that. Now, for the benefit of the people who are just reading the notes, I'm going to write this a second time so you can kind of see what happened. You don't have to do this. This is just what I'm doing to make my notes a little bit easier to read. Is I'm going to do the canceling in this set. Okay, so let me take pink. The x plus 2. I'm totally taking you to Smarytown. And the x plus 2. Okay. And they each leave a 1, obviously. Or perhaps not obviously. I should say that clearly. And then the x minus 2 cancels with the x minus 2. Now, be really careful here. Everything doesn't cancel. Notice this 7. It's okay. It's okay. 7 is actually, 7 is a bit of an introvert, is happy to be at a party by themselves. They're like, woohoo, more chips for me, So up on top, I get 1. Down in the denominator, I get 7. Turns out this problem wasn't as hard as it looked to begin with. Now, this time, let's remember to answer right away. So I think the answer is 1/7, and sure enough, totally randomly, it's the first one. Again, I'm sorry, I forgot to mix them up. So there's the divide and simplify. It's not too bad. That's number 4 is down. Yay. Number 5. Okay. Oh my gosh. Remember what we said about subtraction ruining the party? Addition and subtraction really do hate you. And it's not just a general sense. They hate you personally. They hate everyone. They're just here to ruin our lives, because in order to subtract, we need, dun dun dun, common denominators. Ugh, common denominators. So here's how we're going to do it. We're going to take a look at the two fractions. And I'm going to see that this is 4 all over. And I see something interesting happens down here. I'm going to factor out that 2c. And I'm going to factor out the 2c, and then I get c minus 1 down here. Okay. And then 6 over 2c minus 2. That's 6 over 2 times c minus 1. Okay. Okay. So I need a common denominator between this and this. Now, there's also something else going on in this. I wrote this problem specifically so that you would have yet another option. Notice that if this is fully factored, so all your minuses are inside parentheses where they cannot hurt anyone, this 2 could cancel with this 4. This 2, right there, could cancel with that 6. Now, if you don't see it, skip it. I'm not gonna do that. You'll see at the end, it will work it all out. But if you do see it, it will make the problem just slightly easier. Okay, so my denominator here is 2c minus 1. My denominator here is 2c minus 1. My LCD, I'm going to need a 2. I'm going to need a c, and I'm going to need a c minus 1. Now, do I need to square the 2's? Do I need to square the c minus 1? The answer is no. Because each of these has to fit into here, but not together. They take turns. Okay, that's pants math, right? Okay, so I take, let's see, I need some colors here. I just do. I'm going to go with pink. This is my pink side. This is my pink side. So my pink side is already has the denominator in place, so I don't have to rewrite it. However, I feel like going with blue. I'm going to go with blue. You know what, I could even square it up here so you guys can see where it's coming from. So there's the blue one. There's the pink one. There's the blue denominator. So you'll see that the blue denominator does not match this yet. So I have to rewrite my 6 all over 2 times the quantity c minus 1. And I need the LCD, which is my 2c c minus 1. There's, let's see, yellow. There's my denominator for my common denominator. So what's missing? I've got a 2. I've got a c minus 1. I need a c in there. So I'm going to multiply by c in the denominator and multiply by c on top. Remember, you have to keep it balanced. Okay, so I've got 6c up on top. So what did I do again? I took my two fractions, rational expressions, and I factored the denominators to see what was going on. And then I compared them, and I realized my LCD doesn't have to be that much different. I just need to stick a c in here, and then I've got it. And then my new, so the pink one, doesn't have to change at all. And then my new blue one, which is now 6c all over 2c times the quantity c minus 1. So let's see, I've got my denominator. There's my fancy denominator. This is my pink one. This is my blue one. They each are all dressed up fancy to go to the party. They match. And then, sorry about that, I got another math-avalanche. And then when you subtract, the denominator stays the same. I know this is kind of random, but again, let me remind you that if I have 2 cookies and you take 1 cookie, I still have 1 cookie and probably a little bit of resentment because you took my cookie and now I'm sad. But that's okay because you're my student and you probably were hungry and I would probably say, you know what, you can have my cookie. That's fine. Because I already have one as well. Okay, so there's our common denominator. Does not change. But our numerator, we do the subtraction. Okay, now you'd think we were done. Are we done? And the answer is no. Can I combine terms? And the answer is no, I can't combine these. This is a 4 and this is a 6c, but I can factor out a 2. 2 minus 3c up top. 2c, oops, sorry about that. Like I said, it's going to be a white tape evening, even though this white tape is just all grunchy and grumpy at me. C minus 1. Can I reduce anything? And the answer is yes, I can. I can reduce this 2 with that 2. And then I get 2 minus 3c on top and c times the quantity c minus 1 on the bottom. I'm very excited. Are you excited? I can tell you're excited. We're very excited. Look what's right there. The very first one. Quelle surprise. Am I correct? Who would have guessed that it would be the first one? Just because I haven't mixed up any of the other answers. Yay! Okay. Are you excited? I'm excited. This actually went a lot faster than I thought, so my break time was at the wrong time. The first video is way too long, and this one's going to be nice and short. But this is the word problem, so it's okay. We want you to be fresh when we get to the word problem. So this particular problem has a lot of approaches, so we could do this a lot of different ways. Let's go ahead and read through it, and then let's brainstorm, even though I'm doing this now and you're going to be thinking about it, days or weeks or years. Who knows when you're going to be thinking about this? Maybe on your deathbed, you'll call your family members. You've lived a long life and they all want to know what wisdom you have to impart. And it's your last words before you pass. And then you tell them, a woman can bicycle 30 miles in the same time it takes her to walk 8 miles. She can ride 11 miles per hour faster than she can walk. How fast can she walk? And then you pass on, and then your family members are all like, what? So it could be. It could be. I'm thinking maybe this is the way I want to go. So many, many years, many, many decades from now, of course. I'm already a couple hundred years old. I'm going to live for a couple hundred more years, I think. Okay, so what's important about this problem? Well, 2 things are important. One is this is in, hopefully you recognize the problem. This is written to be just like one of the problems in your homework. This is a problem in chapter 7. And so because of that, there are going to be fractions involved, right? Rational expressions, because that's what chapter 7 is about. So you should go into it kind of anticipating there'll be fractions, but not necessarily, be open-minded, but, prepared. The other thing that I see is we're talking about miles per hour. We're talking about miles, time, fast. That tells me I need a formula. Distance equals rate times. Remember, this is the dirt formula. Distance equals rate times time is dirt. Okay. And remember that the way we wrote this, D equals RT, allowed us to then say, and you can go back and forth however you want to write it, but rate is distance over time. Then I know you're saying, oh, gosh, this is one more thing to remember. But I claim you already know this. So if you didn't hear this in a lecture, hear this now. When I ask you how fast the car is going, and you say the car or the bicycle or the woman is going some number of miles per hour. Miles goes on top, that's the distance. Per means the division. Hour, that's the time. So miles per hour is telling you that your speed or your rate is your distance over time. The other thing you could do is you could take this formula and divide both sides by t. And then you get to this formula. Okay, so we've got the rate is the distance divided by the time. Okay, so I'm going to set up a couple of situations. Okay, a woman on the bicycle. $30 miles. And it says same time. Walking. It's the same time it takes her to walk 8 miles. And it says they have the same, it takes the same amount of time. Now, do we know how much time that is? No. Can we use a letter? Sure. Can we use the letter T? Sure. So she goes 30 miles in T hours, and she goes 8 miles walking in T hours. And these two are the same. That's why I can use T for both, because they're supposed to be the same. So what is her rate on the bicycle? I'm going to write rate with a sub B, because that makes it easier for me to remember that's the bicycle. Is the distance over the time. How far did she go? 30. How long did it take her? T. So far, so good. Walking, her rate, and I'm going to use a W so I tell the difference between these two. Distance over time. In this case, it's 8 miles over, again, T. Okay, so far, so good. So we've got her rate on the bicycle, and we've got her rate walking. Now, what else do we know? Okay, well, let's come back over here, and we see she can ride 11 miles per hour faster than she can walk. She can ride, I'm going to write it down here. She can ride 11 miles per hour faster than she can walk. Underline that with yellow so your eyeballs see that that came out of there. Came out of the problem. Okay, so miles per hour we're talking faster, so that's her rate. So she can ride, that's her rate. And when she says when ride is ride a bicycle. So the rate on the not the basketball. She's not riding on a basketball. She's riding on a bicycle. 11 miles per hour faster than she can walk. Okay, so this is RW. Okay, so are these two rates equal? No. One of these two should be plus 11. Which one? Which one is bigger? She can ride 11 miles per hour faster than she can walk. I claim there should be a plus 11 over here. So if she's walking like 5 miles an hour, then that means 5 plus 11 would be 16 is how fast she can ride her bike. So that makes sense. Okay. So then I have that riding a bicycle is 30 over T equals riding, or her rate of walking, how fast she can walk, is 8 over T plus 11. There we go. 30 over T equals 8 over T plus 11. Woohoo! We're in the home stretch. I know that that's not anyone's, well, it might be somebody's favorite. Fractional expressions, rational equations. sometimes can be really frustrating. But at least we've got an equation. So let's stop here for a moment and say, okay, in all of this, what has to be true? T better not be 0. So she can't bicycle 30 miles in 0 hours. Well, that makes sense. She's not teleporting. So, but T, since we've got it in the denominator, we're putting it in an equation, better not be 0. So there's one of my restrictions. And let's go ahead and see what we can do with this bad boy. So this is number 6. Continued. Now, I realize there are a couple different ways to solve this. The way I know to solve it is to multiply each term by the common denominator. In this case, it's t. Keep in mind that 11 is actually 11 over 1. So I'm going to multiply by t or t over 1. So I'm going to multiply t over 1 times 30 over t equals t over 1 times 8 over t plus t times 11. Remember that I can multiply a fraction by t over 1, and then the whole number gets multiplied just by t. They're equal, right? T and t over 1 are equal expressions. They're equivalent expressions. Okay, so t's cancel here. Thank goodness. They also cancel here. Thank goodness. Make a bit of a mess over here, but that's okay. We can totally handle it. So 30 over here equals 8 plus 11t. Okay, subtract 8. I get 22 equals 11 times t. Divide both sides by 11. You might already know what the answer is. T equals 2. So t equals 2 hours. Now, if you look at all that beautiful work. If you look at the possible answers, one of the answers is 2 miles per hour. Oop. So that's 2 hours. I could circle 2 miles per hour, but then we go, wait a minute, that's 2 hours. That says miles per hour. Oh my goodness, is the teacher actually trying to be nice to me and give me a hint here? And the answer is yes, because hours and miles per hour are not the same. So let's look at what we just discovered. T is 2 hours. What was T again? Okay, so for the bicycle, our distance was 30 miles and our time was T hours. For walking, 8 miles, that was our distance. T hours was our time. What does the problem actually ask? The problem says, how fast can she walk? Okay, so how fast can she walk? Where is that in the problem? Because I got t equals 2 hours. That's not speed. So what's her speed or her rate? And the answer is, this is what we're looking for right there. How fast can she walk? So let me write this out. How fast can she walk? Well, if t equals 2 hours and her rate of walking is 8 divided by t, that means it's 8 divided by 2, which means it's 4. Remember, 8 was miles, t is hours, miles per hour. So there's an extra step. You can't stop it here. Why not? Because this gives you the time, and the problem asks for a rate. So 4 miles per hour. Oh my goodness. We did it. You did it. You guys are amazing. You made it through this brutal word problem. This is not easy. This is a hard word problem, but I'm glad you stuck it out with me. You guys are amazing and incredible. I hope the practice test goes well. Woohoo! Yay! I hope you get a chance to get some sunshine, get some rest, get some vegetables, get some fruits, heck. Drink your milk, eat your oatmeal if you want, not if you're allergic, obviously. You know, do all the things that are good, have some fun, pet an animal, smell a flower, and math on, guys, math on.